Physics Lab 3, Mass of a Black Hole. Table of contents here. Purpose of the lab is to determine the mass of a black hole using data from its interaction with the star. We use GlowScript and Georgia Tech email to create a computational model, then the star's trajectory around the black hole. Then we calculate the gravitational net force of the black hole and the star. Finally, apply Newton's first and third laws to determine the net force. And the next mission is to fly back around the black hole without crashing on the planet of the black hole. To do this, I determine what initial velocity my ship must have when it leaves the surface of the planet. Here are the principles. You can see F net equals F parallel plus F perpendicular, and FG equals G M1 M2 over R squared. And then you can see the derivation of F perp and F parallel. Procedure: put the GlowScript code and calculate the mass of the black hole. Create a code to make a circular loop around the black hole. Use the mass found of the black hole in the second set of code to create a loop for the spaceship around the planet. Added failsafe for in case of crash. Here are the principles again. Oh wait, sorry. These are the initial conditions in the GlowScript code. Here are the formulas in the code. As you can see, here's data with arrows. This is the program running. You can see this is the circle, orbit. Here are the mass calculations, and this is what I got for the mass of the black hole. Here are the initial conditions. Here's me calculating the forces in GlowScript. Here's the program running. And so what does this mean? Oh wait. Sorry about that. So momentum and force represent two different principles. The parallel and perpendicular components of net force are what cause motion in a certain direction, and the net force components can be thought of as the cause of the star's motion and therefore a change in the star's momentum. So instead of taking a quick look at the black hole and leaving, you decide you want to enter into an orbit around the black hole. What initial velocity would your spaceship need to have in order to enter some kind of orbit around the black hole? The spaceship should still not crash into the black hole nor the planet. So to have it start an orbit, it can be calculated through trial and error, reducing the initial speed by one exponent, and we can see the ship in the magenta enters orbit and the planet is the blue. And that's all.